Session we are going to interfacing ultrasonic sensor with ESP8266 and we are going to uploading the data into the ThingSpeak web server. So first let us look at our ultrasonic sensor. So it is a type of sensor that uses sound waves at a frequency higher than the human ear. Can hear typically about 20 kHz to detect objects and measure distance. So these sensors typically consist of a transmitter and a receiver. The sensor emits a high frequency sound wave called an ultrasonic pulse and measures its time it takes for a wave to bounce back after hitting an object. So based on this time measurement, the sensor can determine the distance to the object. So ultrasonic sensors are commonly used in robotics, automation and IoT applications for proximity sensing, object detection and distance measurement. They are typically small in size, low cost and have a high level of accuracy. So ultrasonic sensors can be used in a wide range of environments and can detect objects regardless of their color, texture or transparency. So how it actually works? The ultrasonic transmitter, which is the trigger pin, emits a high frequency sound which is about 40 kHz. So the sound travels through the air. If it finds an object, it bounces back to the module. The ultrasonic sound, which means ultrasound receiver, which is the echo pin, receives the reflected sound, which means echo. So using the sound's velocity in the air and the travel time, we can calculate the distance to an object. So the speed of the sound in air at 20 degrees Celsius is about 343 meters per second. How to find the distance of an object? You have to just multiply time with the speed of the sound in air and you have to divide it by 2 because it transmits and receives. So we have to divide it by 2. So now let's get back to the program. Let me open Arduino IDE. So first we have to include ESP8266 Wi-Fi.h library and then again we have to include Wi-Fi client.h library and then we have to include ThingSpeak library. So ThingSpeak .h library. So the ESP8266 Wi-Fi which provides connectivity function, Wi-Fi connectivity functionality and Wi-Fi client.h. This is used to create a client object to connect to a server and ThingSpeak. This provides a library to send data to the ThingSpeak cloud service. So now we have to add network credentials, right? So now character pointer, I'm going to give SSID which is equal to Pantech and again character pointer which is passphrase which is password and here I'm going to give, this is my password. And now we have to create an object called server. So inside I'm going to pass port which is 80 by default and then we have to create Wi-Fi client object which is client here. Yeah. So now we have to add channel number and API key. So for that let me go to channel, let me create new channel. Here let me give ultrasonic and here I am just going to use two field. One is for I am going to calculate the distance only, right? So distance in centimeter, and I'm going to print distance in inch. For that I'm going to create 2 channel. Let's save this. So here we will get our API key. Here. Now let me get back to the code here. So here I am going to use unsigned long my channel number, which is equal to 1. I have created only one channel, and then constant character pointer. Here I am going to give my write API key. Here I am going to paste this API key. Let me copy this, and here I am going to paste. So then global declaration of timer variable. So unsigned long, I am going to make a variable called last time. I am going to assign this as 0, and now unsigned long timer delay, which is 1 second, 1000. And now we have to initialize trigger pin and echo pin. So I'm going to use constant integer trigger pin, which is equal to D5, and constant integer echo pin, which is equal to D6. So now we have to define the sound speed, which means the sound of the speed in air is, let me define sound speed, which is 0.034. So sound speed variable saves the velocity of sound in air at 20 degrees Celsius. Now we have to define centimeter to inch value. So centimeter to inch value, which is 0.393701. And then I am going to initialize the variables here at globally. One is for long duration, and then I am going to create another one is called distance in centimeter, and also distance inch. So these are the 3 variables I am going to create. Duration, it saves the travel time of the sensor, and distance centimeter, it saves the distance of an object in centimeter, and this will save the object in inch. So now inside setup function we have to give serial dot begin. Instead I am going to pass 9600, and then I am going to print, like we have to connect the Wi-Fi, right? So I am going to first print connecting to, and then I am going to print my SSID. Now we have to use begin function to enable the ESP8266 Wi-Fi. So I am going to use Wi-Fi dot begin. Inside I have to pass SSID and pass phrase, so which is here. Yeah. So then I am going to make a while loop to wait until the ESP8266 is not connected with the Wi-Fi. So while inside using Wi-Fi dot status function, I am going to check this. So which is not equal to WL connector. So here, so inside I am going to make a small delay like 500, and then I am going to print just a dot. So here the Wi-Fi status, the Wi-Fi dot status, this is a function called to the status function which is provided by the Wi-Fi library. It returns the current status of the Wi-Fi connection. The return value could be one of several predefined constants which is defined in the library, indicating that the state of the Wi-Fi connection. And we are taking WL connector. This is the constant defined in the Wi-Fi library that represents the connected state. When the Wi-Fi connection is successfully established, this constant is used to compare with the return value of Wi-Fi dot status. So this is not equal to. This is a comparison operator that checks if the left hand side is not equal to the right hand side of the expression. So this while loop is used to wait until the ESP8266 is connected to the network. And then we have to print the IP address. For that I am going to use serial.print. Inside I am going to print Wi-Fi connector. This is what I am going to print at first. And then serial.print. Let's print everything in new line. So here I am going to print like IP address, and again serial.println. Here I am going to print my IP address using Wi-Fi dot local IP. So using this I am going to print my IP address of ESP8266. So now I am going to use begin function. We have to initialize server and ThingSpeak, right? So server dot begin and ThingSpeak dot begin. Inside we have to pass that client as an argument. So now we have to mention our pin and mode of trigger pin and echo pin. So trigger pin, which is output pin, it just output a wave, right? And echo pin will receive the wave. So echo pin, which is input pin. Yeah, trigger pin is output and echo pin is input here. Now let's go back to the void loop function. So here I am going to generate a trigger pulse to start the ultrasonic wave or ultrasonic sound. First we have to trigger it. We have to make a high-low function for this. So using digital write, first I am going to make trigger pin low, and then I am going to give a delay like 2 seconds, and then again I am going to make my trigger pin high. Just by making low and high, it will generate a pulse. So same trigger pin, now I am making this high. Again we have to give a delay. Let's give a short delay. Just let it be 1 second. So then again I have to make low. We have to generate a pulse. So for that we have to make it low, high, and then again low. So now I am going to read the echo pin now, and I am going to store it in a variable called duration. So duration variable, here I am going to store this. We have already created this in the global space, right? So here it is. So here using pulse in function we can read the echo pin. So inside I am going to give echo pin and I am going to make this high. Then only it will receive that pulse back. So the pulse in function reads a high or low pulse on a pin. It returns the length of the pulse in microseconds. Not microseconds, milliseconds, sorry. Now we have to calculate the distance. So first I am going to calculate distance in centimeter, which is equal to, I am going to multiply this by duration into sound speed, we have mentioned here, right? So sound speed, let me copy this, and you have to multiply by this, and it has to be divided by 2. So duration into sound speed, which is divided by 2. So let me put it in a bracket. Okay. So now another calculation for distance inch. So here also distance centimeter. I am going to multiply this by this centimeter to inch value. So let me copy this and let me paste it here. This is how you will convert centimeter to inches. So now let's print the output in the serial monitor. So serial.print, first I am going to print a message like distance. Let's give centimeter. And then serial print ln. Inside I am going to print that distance centimeter, and then you have to print the same thing for inch, right? So let me change this to inch, and here also inch. So now I am going to give a delay of 2000. Yeah. So now we have to set the ThingSpeak field. So using ThingSpeak dot set field, inside we have to give 1, which is distance centimeter here. So copy this and paste this. So like here, second one is in distance in inch. Copy this and let me paste this here. So let me check once again. The first field is for distance in centimeter and distance in inch. Okay. So now we have to upload the data to the ThingSpeak web server, right? So for that we have to use ThingSpeak dot write fields. So inside I have to pass my channel number and API key. So my channel number and my write API key. That's it. So let us verify this code first. Yeah, the code is error free. Now let's move to the hardware part. So this is our ultrasonic sensor. Let me place it here. So the first pin has to be connected with VCC. We can just give 3.3 volt. And the last pin is ground pin. You have to connect it with ground. And the second pin is trigger pin. Our trigger pin is D5. So it has to be connected with D5. And the echo pin is D6. This is our connection. So now let us upload the code. Yeah, it's uploading. Let us wait for a few seconds. So let me open the serial monitor. It's connecting to the port. So see, now I place my hand in front of this You can see 3 centimeter and 1 inch. If I move my hand, 11 and 4. If I place my hand closer to the sensor, 4 centimeter and 1 inch. Now let us open the chart here. See? No. Yeah. 10, 32, 12. Let me place my hand here. So 4, 1. It will update. So 4 and 1 inch. And you can see the time also. See 1612, 1612. Distance in centimeter is 4 now. Distance in inches 1 now. 4 and 1, 3 and 1. Now let us see. 1612. It is largely updated in 1612. Now time is, yeah, see, 2 and 1. So this is our